Hello, good morning, everyone. Thank you for joining us for Validere's final webinar of 2024. For those of you who don't know, my name is Lindsay Campbell, and I'm a senior advisor here at Validere. I'm joined today by my wonderful colleague, Max Bennett. Max recently joined Validere. Give a good wave, Max. Recently joined Validere as a solutions architect. Max has an educational background in applied math, engineering, and machine learning, and he previously worked in management consulting, focusing on analytics and modeling. At Validere here, he's been primarily working on LDAR configuration while exploring and building prototype solutions for new client use cases. Very lucky to have you, Max, and thank you very much for agreeing to do this webinar with me. I'm looking forward to seeing what you show us in the demo portion of this. So what are we covering today? Well, for our hour together, we're going to start off with introducing you to Validere and our product offerings, and then I'll spend most of our time together today walking through some of the specific Quad OOOb compliance requirements. Today, I've chosen to focus on 3 areas. We'll talk through leak detection and repair, or LDAR. We'll look at compressors, specifically reciprocating rod packing replacement requirements. And then we'll look at closed vent systems and control devices. I found that these source categories require the greatest testing and inspection efforts, so good to focus on for a compliance management webinar. After I go through all of my content, we'll turn it over to Max, and he'll demonstrate our in-product solutions. So he'll be able to connect the kind of theoretical regulatory content that I have with the practical application of our product. So we do have lots to go through today, but I do hope to leave around 5 minutes for questions at the end of this. However, if we don't get to your questions in the webinar, please still submit them in the Q&A on the side there, and we'll certainly make a point of consolidating those questions, and we'll respond to them in a written follow-up. We'll circulate the slide deck and that FAQ kind of document in an email that gets sent around to attendees. And last housekeeping item, we do have one audience poll today. I really hope that you'll take part and encourage you to respond. It's a great way to share our perspectives and to see how others on the webinar are kind of feeling about some of these requirements. So who is Validere? Validere offers a platform for emission management that streamlines field data collection, emission quantification, and reporting. The platform supports compliance with both regulatory and voluntary frameworks, integrating with existing systems to deliver actionable insights and accurate reporting. As illustrated in the diagram that you can see on this slide, the Validere platform collects and centralizes a pretty wide range of data that's essential for compliance and emission management. It includes things like asset and equipment inventories, operational data, emission event records, volumetric data, measurement data, and field inspection results. And lots of field inspection results will be coming your way if we look at the Quad OOOb requirements. This comprehensive data set is used to perform emission quantification, to help manage field operations, and really to support regulatory reporting and your overall compliance objectives. So at Validere, we offer 2 product packages. We have emission management and field data workflows. Emission management provides emission quantification to satisfy those regulatory and voluntary reporting requirements. You can see a handful of those listed on the slide here. While the second offering, field data workflows, is really to support field data collection and that ongoing compliance task management. This feature package allows for both online and offline data collection and capture, task tracking with customizable forms, and the attachment of visual evidence to those inspections. So the regulatory content that I'll talk about today and the product features that we discuss and Max walks us through are really aligned with this particular product package. Okay, so in the next few slides, we'll keep it higher level. I'll provide an overview of Quad OOOb, and we'll focus on more of the scope and applicability of the regulation. The goal here is to contextualize Quad OOOb as really just one component of the broader new source performance standards framework. With the introduction of Quad OOOb and then the anticipated implementation of Quad OOOc, it's pretty clear that there's this growing complexity to navigate all of these requirements. Okay, so before we really get started and into the regulatory content, we'll add a bit to our final webinar of the year. Like many EPA regulations, Quad OOOb is this nice light read. You have just over 200 pages of bedtime material for those of you that have already dove into it. If you haven't, then you have 200 plus pages to look forward sifting through. Okay, so to start at the highest level here, sections 111B, the new source performance standards, and 111D, the emission guidelines of the Clean Air Act, recognize that new and existing sources are different, and they need different considerations when establishing standards. So the EPA establishes standards for new sources that reflect what's called the best system of emission reduction. These new source standards also require review at least every 8 years. So nice to see that kind of embedded review cycle in there as well. EPA also establishes emission guidelines for existing sources, which states then use to establish their state plans. So those plans can actually take into effect additional considerations, such as remaining useful life of a source when they're establishing those specific requirements. Each state is required to submit a state plan for EPA approval. And in cases where a state either chooses not to submit or the plan is not approved by the EPA, sources in those states must then comply with the federal plan that is issued by the EPA. So most recently on March 8th of this year, and then in effect on May 8th, of this year, 2024, the EPA published their final rule that was titled Standards of Performance for New, Reconstructed, and Modified Sources, and they published emission guidelines for existing sources. This published rule finalized a lot of different actions, including the new source performance standards that we see in Quad OOOb that we'll go over in more detail, but as well as the emission guidelines in Quad OOOc. Now, the table that I show here really focuses on new source performance standards that have been released over the last 12 years. But something that I want you to keep in mind is that each state with a designated facility must still develop, adopt, submit to the EPA those state plans under Quad OOOc, and the timeline of that is submission of those plans by March 9th, 2026. So while the details of each standard are certainly important, the real point of this table is to highlight the variation in those applicability dates, both the applicability dates, the pollutant targets, and the source coverage that we see in each of those iterations of the Quad O's. Really, we've seen each publication of each rule expand in scope. Now that means that operators have to manage different sets of requirements on different assets, which is just adding, again, more complexity to this space. So to take that concept one level further, we look at the source categories, or what are called affected facility types, of Quad OOOb, and we evaluate which site types have to manage those sources. So we have super emitter events, well sites, well completions for hydraulic fracturing, associated gas, liquid unloading, compressors, process controllers, pumps, storage vessels, and fugitive emission components. So pretty much anything that can release emissions at a site are then managed, and mostly managed at every single site type. I've adapted this particular table from, there's a US EPA Small Business Compliance Guide, which I'll send the link out as well in the follow-up material. I found this guide very useful. If you haven't had a look at it, I suggest you do. This guide really provides more of the detail on those named exemptions that I've highlighted in the table here. But again, the point here of this particular table is to summarize which sources are subject to emission management requirements, and then highlight that those requirements also have nuanced application based on the site type as well. Okay, I promised you a poll. Here is our first poll of the session. Let's see, is that showing up there? Beautiful. Okay, I encourage you, like I said, please respond to that poll. What we're asking you today is what compliance requirements of Quad OB are you expecting to be the most challenging? Is it understanding exactly what you need to do and when, sifting through all those different applicability dates and what applies at what site? Is it the actual coordination and execution of field compliance inspections? Are you thinking about the tracking and the tracking of testing and ongoing monitoring requirements? Is it managing the influx of data that's coming in, both the field data from all of the inspections or the continuous parameter monitoring data that's coming in as well? We'll talk a little bit about that later on. Or is it the elusive super emitter events and investigating and responding to those? So I would love to hear your responses to that. Lots of complexity to manage. I didn't give an easy out where you had all of the above, because I find that people usually select that. So you don't have that one today. So pick from one of the others. Okay, so now let's look at our 3 source categories in more detail. We're going to start here with leak detection and repair. So here we show a table that summarizes the audio visual olfactory, or AVO, and the comprehensive optical gas imaging, or OGI, or method 21 survey frequencies by site type. If we look here at the first row, single wellhead only sites require quarterly AVO. Now, I think it's important as we're going through these frequencies, I've also pulled out the EPA definition for what that site type actually means. The first 3 site types that we see here have newly introduced definitions in Quad OB, and I think really understanding these definitions is important because then you can categorize your facilities correctly and apply the correct frequencies to those facility types. So for this first row, what we're talking about here is a single wellhead only site, which means a site that contains only one wellhead, but it also has no major production and processing equipment. Okay, well, what do they mean by production and processing equipment? Well, that means reciprocating or centrifugal compressors, glycol dehydrators, heater treaters, separators, control devices, natural gas driven process controllers or pumps, storage vessels or tank batteries that collect crude oil, condensate, intermediate hydrocarbon liquids, or produced water. So really, bare site, one wellhead only. Excuse me. Next, on the next row, we go into small well sites, and these small well sites, similar to the first row, quarterly AVO and no ongoing comprehensive surveys. So what does a small well site mean? A small well site means a well site that contains still a single wellhead, but no more than one piece of certain major production and processing equipment and associated meters and yard piping. These small well sites cannot include controlled storage vessels or controlled tank batteries, control devices, or natural gas driven process controllers or pumps. So you have these sets of small sites that typically have one wellhead and a certain level of production equipment, one piece. So getting that inventory of all your assets, properly classifying your sites so that you're executing quarterly AVO inspections at these facility types. And then we move into multi-wellhead only sites. These are sites that require both quarterly AVO, and now we see the introduction of those ongoing comprehensive surveys. For this site type, it is at a semi-annual frequency. And what does multi-wellhead only site mean? You have a well site that contains 2 or more wellheads and no major production or processing equipment, again, based on that definition that we went through at the first row. And now here we have well sites with major production and processing equipment. These sites require bi-monthly AVO and quarterly comprehensive surveys. Now, in this rule, well site means one or more surface sites that are constructed for drilling and subsequent operation of any oil well, natural gas well, or injection well. What I wanted to note here is that a well site does not include Class 1 or Class 2 oil field disposal wells or disposal facilities. Moving on to centralized production facilities, these facility site types require bi-monthly AVO and quarterly comprehensive surveys. Okay, so again, definitions here. Centralized production facility, or CPF, means one or more storage vessels and all equipment at a single surface site used to gather for the purpose of sale or processing to sell crude oil, condensate, produced water, or intermediate hydrocarbon liquid from one or more off-site natural gas or oil production wells. So this gathering site, meeting that definition, is bi-monthly and quarterly frequencies. Moving on to compressor stations. Compressor stations require monthly AVO and quarterly comprehensive surveys. Again, going through the kind of formalized definition in the requirements, and I think there's a bit of a nuanced element of this as well. But compressor station means any permanent combination of one or more compressors that move natural gas at increased pressure through gathering or transmission pipelines or into and out of storage. This includes, but is not limited to, gathering and boosting stations and transmission compressor stations. Now, this is the note to keep in mind. The combination of one or more compressors located at a well site, centralized production facility, or an onshore natural gas processing plant is not considered a compressor station for the purposes of fugitive emission management. And last row here for natural gas processing plants, a little bit more complexity here, but these requirements have existed for quite some time. So you have inspection requirements for certain pieces of equipment. For example, you have weekly visual inspections for pumps in light liquid service. You have pressure relief device monitoring within 5 days of each pressure release, as well as bi-monthly comprehensive surveys. That EPA Small Business Compliance Guide that I mentioned a couple of slides ago, they have a really good summary table on all of the monitoring requirements for natural gas processing plants. You can go and have a look at that as well. So taking a more detailed look at the LDAR requirements for well sites in particular, we see that monitoring events are not only differentiated by site type, like we just talked about, but they're also differentiated by this initial monitoring requirement and periodic monitoring requirement, meaning that operators must kind of start their LDAR monitoring clock once production starts, conduct those initial monitoring surveys within 90 days, and then you get into that periodic monitoring rhythm. But then it's not just about the inspection requirements, it's also about repairing and closing those leaks out. So you layer on these repair requirements. These repair requirements have their own specific timelines as well, and you can split those, or the rule splits those into both the first attempt at repair and final repair. Note that there are delayed repair considerations that do allow operators to move outside of those 15 to 30-day windows that are noted here. So delayed repairs are allowed when a repair is technically infeasible to conduct, it's unsafe to conduct the repair, or if the repair would require blowdown or shutdown. So what this all means is that operators now have to manage and track which leaks are closed and repaired within those timelines, or repaired and closed and confirmed within those timelines, and which are on delay repair, so you can ensure those compliance deadlines, the variable compliance deadlines, are met. And just another example of a non-complex process to manage. This is now looking at central processing facilities. I just wanted to walk you through this flowchart or decision tree a little bit. Again, this is found in that small business compliance guide. And I think it just serves to highlight that there are lots of pathways that you can go down when you're looking at executing these compliance management tasks. So you start off there, you develop a fugitive emission monitoring plan, you conduct your initial survey, like I said, initial and periodic monitoring surveys, and then anytime no fugitive emissions are detected, you can move down that left-hand side. But whenever you do have fugitive emission detections, you move down that right-hand side, get into the repair requirements, the resurvey requirements, and closing off those leaks, all kind of combined with record keeping and reporting requirements as well. But if we move down the left-hand side of this tree, no, we haven't detected fugitive emissions in that initial survey. Now we're getting into that periodic monitoring frequency. We're starting to conduct our AVO inspections, our ongoing OGI or Method 21 inspections. And then for central processing facilities, you're also layering on what other pieces of equipment exist at that site. Or for any site, what other pieces of equipment exist there? Do you have uncontrolled storage vessels? Okay, well, now we have visual inspections of thief hatches. Do you have a separator? Okay, now we have visual inspection that all separator dump valves are free of debris and not stuck in an open position, and repair requirements for any dump valve that's not operating as designed. So lots of different compliance pathways there, all tagged with record keeping and reporting requirements. So I thought that was an interesting decision tree to kind of walk through for one particular site. Each site would have its own decision tree like this. Okay, so to bring this section together, I've summarized the compliance management activities for LDAR, and now I introduce the Validere platform features that have been developed to provide support for that particular activity. Max is going to show you these features in a bit more detail soon. But what we have here for tracking site and asset data, we manage that through what's called custom attributes. Those custom attributes live at both the emission source and the site level. We also have forms and workflows that really support the bulk of the field level compliance management activities, including conducting your inspections, tracking and conducting repairs, and that leak closure piece of it as well. We then source all of that information that you've collected and use it to quantify all of those associated fugitive emissions that are then available to export in the form of custom or templated reports. Okay, so next group of slides here, we'll look at reciprocating compressors. This is a slightly less complicated source category, but still certainly some ongoing compliance activities and a couple different pathways that you can elect to go down for managing reciprocating compressors. So here, a summary table of the requirements and the applicability definitions of modification and reconstruction when it comes to compressors, which I think is something to pay attention to. But if we focus here on the fourth row, we'll see that the rule does allow for a few different compliance pathways. Operators could test their rod packing flow rates and replace if you find those flow rates are above 2 standard cubic feet per minute. Or you could track hours and just replace those rod packings every 8,760 operating hours. Or you have the option to just route those emissions into a collection system. If you do choose to control or route those emissions, you're no longer subject really to the reciprocating compressor requirements. You almost shift into the category of managing this source by closed vent system requirements and control device requirements, which we'll get into in the last section in a little bit here. Okay, so depending on which compliance pathway you choose for reciprocating compressors, you'll have to kick off either volumetric flow measurements You'll also have to track hours to conduct those ongoing measurements if you're conducting those annually, or if you elect to go down just the rod packing replacement, you'll want to be tracking hours so that you can trigger those rod packing replacements. Or again, you're managing your compliance requirements through the controlled vent system and the closed vent system and controlled device sections of the rule. So back to kind of wrapping this section up, like I said, a little bit less complex, so we can go through this one a little bit faster. But the compliance management activities and Validere features, again, you have the same feature sets here that can be applied to tracking asset data. Now we're including operating hours in that asset data, informing on when to collect measurements or replace rod packings, and quantifying and reporting emissions. Okay, before I turn it over to Max, I do have one more section to go through here. Like I said, the third section that I wanted to focus on today, closed vent systems and control device requirements. So here I've summarized the performance testing and inspection requirements for closed vent systems and controlled devices. Note this is a very simplified summary of all of the performance testing and inspection requirements within each of these boxes. There's a lot of complexity in what is actually required. We'll get into a slide that highlights some of that complexity in detail soon, but at a high level, we're looking at closed vent systems requiring initial inspections within 30 days of startup using either OGI or method 21 with no identifiable emissions. Maybe you've heard this term come up. It's come up to me a couple of times. I've seen it in the context of the industry petition for reconsideration of this rule as well. So no identifiable emissions means that no emissions are detected by AVO if you're doing an AVO survey. No emissions are imaged with an OGI camera if you're conducting an OGI survey. And equipment is operating with an instrument reading of less than 500 ppm above background as determined by method 21 if you are conducting surveys with method 21. So just thought it was useful to understand what that no identifiable emissions definition means. We have closed vent systems as well, also requiring ongoing AVO and OGI or method 21 inspections. These are typically required at the same inspection frequency that aligns with the LDAR frequency for that source. So nice to have alignment there in some of those ongoing compliance monitoring frequencies so that you're not having to typically have two sets of schedules going, though I'm sure you have lots of sets of schedules going. And then there's also a requirement for annual visual inspections. If we move on to control devices require both initial and ongoing being every 5 years, performance testing, continuous parametric monitoring. This, I think, is a really big one for this control device category, and periodic inspections. Just to note on that last kind of box of this slide, in lieu of a performance test, an operator or an owner can actually use a control device that has been tested by the manufacturer. If it is posted, I've hyperlinked the link here, so when you get the slides, you'll be able to go and have a look at this reference document, but it's an EPA consolidated table of about 50 to 100 control devices that they say are eligible that meet this clause in the rule that have been tested by the manufacturer. So if you have control devices, it's worth going to have a look at this list to see if yours is on there. Okay, parametric monitoring. So to dive a bit deeper into one particular type of control device, to look at what is meant by this concept of parametric monitoring, I've put together a summary table here for flares. And we see that for flares, the parametric monitoring requirements entails continuous parameter monitoring. And what that's looking at monitoring is flow rate, net heating value, and pilot or combustion flame presence. There are also requirements for visible emission inspections and assessment of flare presence that's required to be completed at each AVO or OGI monitoring event. So note those kind of ongoing parametric monitoring requirements that also mean data collection, record keeping requirements as well. Now, something to note, there is an alternative to the continuous monitoring element of net heating value. You may perform initial twice daily for 14 consecutive days, initial sampling and periodic resampling, which is every 5 years, to determine that net heating value of the vent stream. And also as an alternative to the continuous monitoring of the inlet gas flow rate, you could install a back pressure regulator valve that is calibrated to open at the minimum pressure set point corresponding to the minimum inlet gas flow rate. So a couple of alternatives there. Keep those in mind as I get into the content of the next slide, because there's maybe some movement or flexibility on those monitoring requirements. I wanted to briefly expand past Quad OB and move slightly into subpart W for one slide. I wanted to highlight here in this slide the connection between the Quad OB flare monitoring requirements and the ability to use and access Tier 2 combustion and destruction efficiencies. So you can see that Tier 2 combustion destruction efficiency laid out there. Operators would be well served to track which flares are complying with those Quad OB monitoring requirements to then be able to use those slightly higher than Tier 3 efficiencies in their subpart W calculations. The other thing that I wanted to note for you is on the right-hand side of the screen here is the update. The EPA has agreed to progress 2 items that were put forward in that industry petition for reconsideration that I mentioned. The 2 items in particular are the net heating value monitoring and alternative sampling demonstration requirements. So the monitoring that we talked about in the last slide, they are reconsidering that, and also the temporary flaring provision for associated gas in certain situations. In October of this year, EPA did provide a draft rule that addresses these 2 elements. They provided that to the Office of Management and Budget. I tried to Google and look for what that draft rule looks like. I wasn't able to find it. If someone else has found it and knows where it is, feel free to reach out and send the link. But just something to note that those 2 particular elements may change. So something you probably want to maintain some awareness of as you plan your approach to net heating value determination and monitoring. Okay, so to bring this section together, once again, we're tying in the compliance activities with Validere features. We're seeing here that we have custom attributes, forms, workflows, estimation methods, and templated reports supporting, again, the similar compliance management activities, applicability assessments, tracking asset data, those initial and ongoing performance or monitoring requirements, and the field data collection, both from the field inspection side of things and also the data that's collected as part of the continuous parametric monitoring, and then using and sourcing that information through quantification and reporting. So let's take a minute and just have a look at our poll results here before I turn it over to Max. Okay, so remember our question. What compliance requirements of Quad OB are you expecting to be the most challenging? Some interesting splits. People aren't as concerned with the super emitter event. I wonder if that'll go away. So our highest vote, understanding exactly what you need to do and when, which makes sense. That's the first step in this whole process. Hopefully what we're providing today provides a little bit of clarity there. And then again, my plug for that compliance guide. They have a lot of nice summary tables and decision trees in there if you want to go and look that up. So, and I think learning and talking from peers as well is something that we've found to be very effective. So if you do have anything to share, even in the chat, that you've learned about what's coming in 2025, feel free to pop that in there as well. And keep voting. We'll maybe check back on these results at the end again, but it looks like it's fairly unanimous in that understanding what you need to do and when. So with that, Max, I would love to turn it over to you to show us what those features look like that I've been talking about, how they work in the product, and making that connection from regulation into some of our product solutions. So I will happily turn it over to you.
Awesome. Thanks a ton, Lindsay. So to show a bit more what this compliance management configuration looks like in the Validere platform, I'm going to walk through a demo in a moment that specifically looks at an LDAR configuration and how leak detection and then the associated repair and confirmation is carried out, and then how the associated fugitive quantification takes place. So to kind of point out what these features look like in the Validere platform, we are, among other Validere platform features, we're using forms, workflows, and triggers to set up a system to capture initial inspection information, as well as the details of any follow-on corrective actions, so that the associated quantification of fugitive leaks can take place. And this can be done through the Validere web app, which is what we're going to be doing for our demo today. It can also be done programmatically through APIs and file uploads, and then also through the Validere mobile app, which is available for both iOS and Android, and is typically where we expect a large portion of the workflow management and form submission activity to take place for a typical LDAR configuration. But for the time being, for today, we're just going to look at the web app in this demo. So to lay out what this compliance management configuration looks like in a bit more of a visual manner, it starts with a set of customized and predefined inspection schedules. And these are going to trigger a set of recurring inspection workflows based on some predefined cadence. And as part of these inspection workflows, a set of forms are required to be submitted, which outline all the details of those inspections. And then based on the submissions to those forms, one or more corrective actions can possibly be triggered if any issues or leaks are identified. And those corrective action workflows involve the submission of forms to document the repair and verification, and then the quantification of the associated leaks. And so to recap, the forms here are where we're capturing information from initial inspections and follow-on corrective actions. The workflows are how we are setting up the sequencing, the due dates, the notifications, and the task assignment involved in the completion of those inspections and the associated repairs. And finally, the triggers are how we tell those workflows when and how to take place. So at this point, I'm going to flip over to the Validere platform and start off with our dashboard feature. You're going to see on the right that we're in the dashboards right now, but throughout this demo, we're going to move into the workflow section and then the forms and the records and calculations as we do the quantification piece at the end of this demo. So starting here in the dashboard, this is a LDAR dashboard for the recurring inspections. So this outlines all of the inspections, the AVOs, OGIs, method 22s that need to take place on some recurring basis. It gives us a breakdown of those inspections by status, and then we can apply some filters if we were interested in looking at a specific subset of these inspections. For right now, I've just have it filtered to those that are in progress or overdue. But obviously you could look at those that have been completed as well. So I'm going to drill down into one of these specific workflows and walk through the process of completing the initial inspection, identifying a leak, and going through the follow-on steps involved. So I'll click into this inspection workflow for this monthly AVO inspection at the Brighton facility. And if I click in here, it's going to take me to that workflows tab in the Validere platform that I just pointed out. And you can see we're in a monthly AVO inspection workflow. It's at the Brighton facility, and it's got a due date for the end of the month. And so this workflow, the inspection workflows are fairly simple. They just involve the completion of that inspection and the submission of the associated form. So there's under this action section, we're only seeing one single action here. So if I click on that action, I have the ability to add a form submission, and I'll create a new submission. We can see that this form submission is associated with that AVO inspection workflow and that form submission task. And now this is a very simple version of this AVO inspection form, but it's entirely configurable. So if there's any additional information for the inspection that we wanted to add in, we could add questions for that. But for the time being, there's a simple set of general information that's all pre-filled for me. And then I have the opportunity to add one or more leaks that were detected during this inspection. And so for the sake of simplicity, I'm just going to fill this out one time. I'm just going to indicate there was one leak found. So I can say, yes, there was a leak or release detected. And let's say it took place on a compressor. So that'll be our equipment, and I'll put compressor for the component as well. For the leak tag, I'll just input one that I have pre-saved, which uniquely allows us to identify this leak. And then I have a set of follow-on questions to indicate whether a repair was attempted and or confirmed. And so let's say that we attempted a repair. I'll just use the pre-filled date that's based on when we're filling this out. And the corrective action taken, let's say that we replaced the equipment. So we replaced our compressor, and that the repair was successful. So I can indicate that compressor successfully replaced. And now for repair confirmed, I'm going to hit no here just so we can see what this looks like in the follow-on corrective action, because this is an essential step in closing out that corrective action. So I'm going to leave it as no, and we'll see what happens down the road. We'll indicate that it was the leak rate was measured at 5 cubic feet per hour. And yeah, this was measured. And let's say it happened at standard temperature and pressure, our measurement, and the release type was leaking. So I could add additional defect leaks or releases as part of this inspection, but let's just keep it as one for now. And if we submit this form, we're brought back to that workflow, which if I refresh, you'll see that the workflow has been completed. So the one mandatory step involved in this workflow, that form submission, is done, and this monthly AVO inspection at the Brighton facility has been closed out, and that form submission is complete. Now, if I go to the workflows portion of the product and I go back to all workflows, we're going to see that there's a new leak corrective action workflow here with that unique leak tag that I had pointed out earlier. It's due on January 4th, so 30 days from the time of detection of that leak, which is configurable, but we've got it set up for 30 days as of right now. And you can see it was created today on the Brighton facility. So if I click into this workflow, this is now a separate workflow, a leak corrective action workflow. We can see this is in progress. It's at the Brighton facility. We have all the information about what triggered this workflow. So if I wanted to, I could click into this AVO inspection form submission, which is what I just submitted, and get all that info. So if someone different is filling this leak corrective action form out, leak corrective action workflow, they would have all the information at their disposal, even if they didn't complete the initial inspection. And now if I scroll down to the actions here, you can see that the open action is to confirm the leak repair and submit this leak corrective action form. So because we attempted a repair and the repair was successful, all that's left to do is confirm the leak and confirm the leak repair and submit this leak corrective action form. And then we'll see in a moment there's going to be a quantification step at the very end. So if I click into this task, I'm going to add a new submission. And now we have a leak corrective action form. So it's a different form, but we can see a lot of the information has been pre-filled from that inspection form. So if I'm the one coming in to fill in this confirmation form, I don't need to pre-fill the information about the detection of the leak or the information about the initial leak repair that has already taken place and was successful. So at this point, let's say that I did in fact confirm the leak, and I'll adjust the confirmation time to be a bit later, and let's say it happened at 5 p.m. today. And we get a confirmation method. Let's say we did a repeat AVO to confirm the leak was repaired. and I have all my release details that have been pre-filled down here. And so that's done. We've added our leak confirmation or a repair confirmation, and we are good to submit this leak corrective action form. Now, if I reload this workflow, we can see that we're still in progress, but we've completed that confirmation of leak repair. We've completed that task, and now we just have one task left, which is to submit this leak quantification form. So if I click in here, add a form submission, we're going to see that everything is pre-filled in the same way, and essentially this form looks a lot like the one we just filled out. We now have all the details about our leak confirmation that we didn't previously have. And at the bottom, we have a leak quantification section, which is pre-filled with that info from the release details in the previous forms. So just to make this a bit more interesting, I'm going to go back to the top, and although I have this date issue identified from when I filled out that inspection form, I'm going to overwrite this and make it so that our leak duration is non-zero. It's not like I've found the leak and repaired it on the spot. Let's say that the leak was detected at noon on December 1st. And if I come down to the leak repair, let's say it was repaired at noon on December 3rd. So now if I go down to the bottom to this leak quantification section, in addition to the release details, I also have a leak duration and leak volume. So that leak duration is calculated as, right now we're just doing something simplified where we're just taking the difference between when the leak was identified and repaired. But in theory, you could configure this to handle the more complex logic of leak duration for OOOOb. So for right now, I've just taken that 48-hour difference between the leak repair and when the leak was identified, which is calculated based on those fields above. And then finally, the leak volume, which is calculated based on the leak duration and this leak rate that I inputted here. So if I submit this, we'll see that this workflow, if I refresh it, has been completed. So I've closed out this leak corrective action, I have repaired, I've confirmed, and I've quantified this leak. And so we're all done here. Okay, now that finishes things off for the workflows. But if I now go to the records portion of the platform, and let's go to December, and I'm interested in the subpart W reporting scenario, which is where I'm going to quantify the fugitives. And if I go to flows, which is where I find my fugitive release volumes, and let's look up that facility, Brighton, we see that we have a Brighton fugitive emissions flow, which is where the volume can be written based on the inspections that we just completed. So over here, we don't currently have a leak volume, but if we apply this default record automation, this will pre-populate with the leak volume that we submitted as part of that inspection form. And if we submitted another inspection form or another corrective action form on this same facility, it would add the leak volume from that additional corrective action form. So we have 240 standard cubic feet associated with this facility during the month of December, and this is saved as a record on this Brighton facility. Now, in terms of what I can do with that, I can now go to the calculators portion of the web app, and I'm interested in the emissions calculations, and I want December and subpart W. And now let's filter down for that Brighton facility. So if I look up Brighton, where I just submitted that leak corrective action form and got that record on the facility, and scroll across, you can see that currently we don't have any emissions results associated with this facility for the month of December. However, I can apply the configuration which pulls in that record value that I just showed on this Brighton facility based on the fugitives we identified in the inspection and the leak corrective action. And we can see that our calculator should be ready. And now if I run it by hitting calculate, we can see that we now have a mass of CO2, CH4, and CO2 equivalent based on those that fugitive volume I identified. And I can click into this result and see the information about the calculator being used and the formulas used to compute the outputs. I can see the information about the inputs used in this calculator. And finally, I can see the results of this calculator at the top here. And so we've taken everything full circle from the recurring inspections to the leak corrective action associated with a leak we found during that inspection, identifying the results of that leak. And lastly, I'm going to flip back to the dashboard that I was showing earlier. And we started off with this recurring inspections dashboard. Now the results of the emission calculation I just walked through would actually show up in this fugitive emissions dashboard, which is where everything is being aggregated across all of the facilities and all the equipment in our account here, based on the fugitives identified during those inspections and then quantified during those leak corrective actions. And we can see a breakdown by facility. We can see a mapping of where those fugitives are taking place and where they're concentrated. And we can see how the fugitive emissions are trending over time, as well as a visual to understand how the facilities compare to one another. And then lastly, I'll finish off with a dashboard that shows information about the corrective action. So we saw a similar dashboard at the start for the recurring inspections. Now, for any leaks that are identified, those create corrective action workflows as I walked through, and we're seeing that there's a total number of leaks identified, and we have a breakdown by the status of those leaks. We can also understand what those leaks look like in terms of those that have been placed on delay of repair, pending repair, pending successful repair if there's a failed repair attempt, pending confirmation, and then finally pending quantification. And we also have a breakdown by the location of these leaks, a breakdown by facility, and also a trend over time of where those leaks are taking place. Great, so I think that rounds out our demo of how the platform supports leak detection and repair through this compliance management configuration. And I think with that, I will hand it back over to Lindsay to finish off our presentation here.
Great, thank you very much, Max. That was fantastic. Let me find where I'm at here for our last couple of slides. Okay, so the last thing I wanted to touch on here before we do have a few minutes, and I'll walk through some of the Q&A that we've been receiving over the course of the webinar. If you have any questions for Max too, based on what he went through, make sure you pop those in there. But here, what has Validere learned so far? We've been implementing some of the solutions that Max reviewed. We've certainly identified some challenges, and we've identified a few keys to success. So in terms of challenges, what has Validere learned so far when it comes to compliance management rollouts? Tool modernization, so training operators to use tools that are just different. Change is challenging, and new tools, goodness knows, I struggle with the use of new tools. So there is that learning curve as well. And then a standardized approach, so delivery of these kinds of solutions in a way that is tailored to meet clients' needs, which can tend to evolve over time as well. Some of the keys to success that we found are really in-person engagement. So having those opportunities to have conversations in person and learn from those individuals who are implementing these solutions, and then having a deep understanding of really what the processes are, what the data collection requirements are, and bringing that back to inform our product development. Okay, so I'm going to pause there. Like I said, we have a few minutes for questions before I kind of close out and say thanks to everyone. So let's start, well, one with the easiest one. Someone asked about whether this presentation will be available. Yes, it will be available. We will send that out via email to all attendees, along with some of the links to the reference documents I've mentioned here as well. Okay, we had a question, how do AVO inspections get recorded? This was when I was going through my content. Hopefully that became more clear, at least when it comes to Validere's solution for this, is through the use of our forms feature. So we create fields within those forms that align with both the record keeping and reporting requirements of regulations. So those were the fields that Max would have walked through there. Good comment from Jerry. So thank you for sharing that comment, Jerry. The difference between AVO inspections and annual visual inspections. If you look through the Q&A, I sent off a link to that compliance document, which I said will circulate with attendees as well. But annual visual inspections are more required for looking for things like defects, looking for, say, debris in those separator dump valves, looking for the presence of flares, or visible flame at your flares, whereas AVO inspections are fugitive emission inspections that are conducted using audio, visual, olfactory means for all components that have the potential to release fugitive emissions, unintentional emissions. Federal regulations that apply to all states, correct? Yes. You mentioned that states can submit a plan equivalent to an alt-FEMP here in Alberta. Excuse me. For those of you who aren't familiar with alt-FEMP, that stands for Alternative Fugitive Emission Monitoring Program or Management Program. And that is the use of technologies that are not OGI or Method 21 at a certain frequency that still meet the same outcome of those standard methods. So what we're talking about here for Quad OC and state level plans is not the same thing. Those state level plans are a broad kind of set of standards and requirements that align with the requirements in Quad OC. So states have the opportunity to develop those themselves. 5 more minutes. Okay, good. Dan, good follow-up question there. Hopefully I provided a bit more detail if you have a look at that table 14-1 in the document I provided as well. Can a third-party vendor have access to the inputs for LDAR inspection? Okay, so this is, I think, a product-related question. We would welcome you to reach out to us directly, and we can talk about how third-party vendors can use and interact with our platform as well as a tool that can help them support their clients. And then I think there were a couple in the chat. Okay, so yeah, the couple from the chat, the storage field one, the requirements in Quad OB are dictated by emission source. And then when it comes to storage field, I think using your best judgment for what equipment is located within the storage field and how that aligns with all of the site definitions that I read out in a good level of detail. And if you have some more commentary on that, Vanessa, please do let me know. And performance testing. Okay, and then Daid, I need to go and follow up on this one. I would assume that manufacturers are also subject to retesting requirements, but let me confirm and we'll kind of, like I said, consolidate all these responses and send them out in a document for you. Okay, with our last couple of questions there, I'll take a quick look at that poll, see if anything changed there, and we'll get into our last couple of slides. Okay, there you go. Thanks, Ronnie. Okay, just more of the same trend here. So understanding what you need to do and when. I wish you good luck with that. There's lots to understand, but again, hopefully we provided a little bit of value here today. Ronnie, I'll go back to my slides here. Thanks. Okay, so I couldn't hold my last webinar without one well-curated quote. I typically incorporate these in most of the presentations I do. None other than Winston Churchill himself. Those who plan do better than those who do not plan, even though they rarely stick to their plan. And when it comes to compliance management under Quad OB, I certainly agree with this quote. Make a plan, get yourself set up well for 2025. And if Validere can support you in any of those efforts, we would more than welcome that opportunity. So please reach out if you have any follow-up questions. Thank you all so much for joining us. And I wish you all a joyous holiday season and all the best in 2025. Thanks.